Hello everyone and welcome to the emulated virtual environment session. Today I will explain how to install the Cisco EVE-NG simulator and learn how to load different router, switch and firewall images. By the end, you will be able to use these images to build and simulate a wide range of network environments for practice and testing. Let us see the installation procedure. Before proceeding with the installation, we need to download the Community Edition ISO for Cisco EVE-NG from its official website. And you need to choose a choice of your hypervisor. In this case, this is going to be VMware Workstation Pro. Let us open the VMware Workstation Pro. Click on the File menu, select the option Create New Virtual Machine, and installation method is typical. And browse the ISO file and provide the virtual machine name and location. Once the name and location are provided, and select the disk size, which is 20 GB by default. And we recommend you should give at least 100 GB. In this case, I am providing the 200 GB. Let us check with the compute requirements. The only important thing here is you need to enable the virtualized Intel VTX or EPT options. And apart from this, how much amount of memory that you want to allocate and how many number of CPU cores that you want to allocate, it is subjected to the availability on the host hardware. And once everything is allocated, click on the finish to spin off the virtual machine. While our EVE-NG machine is getting powered on, let us remove some stale entries that I have created previously and reorganize the sections. Once the reorganization is done, let us see what is the status of my EVE-NG machine. The EVE-NG installation basically in progress, and if you see here, the EVE-NG is developed over the Ubuntu operating system. You have to select your language and you may get a prompt to wipe the disk. Yes. Once you have prompted with the installation will be completed and the system will prompt for a reboot. The EVE-NG installation is completed. Post installation, system will go for a reboot. Post initial reboot, we will get a login prompt and the default credentials are shown in the windows by the system. Those are username root and the password is EVE. Post authentication, we will get the initial configuration dialog where EVE-NG prompts for a new password. We can provide the password or we can provide the same password. Do not change the host name or domain name. Select the IP address method as a static and IP address parameters and proceed with the configuration dialog. In the last step of the configuration dialog, the EVE-NG will be rebooted for the second time. Okay, we have provided the DNS servers and internet connection as the direct connection. Now the system is going for a second reboot. Post this reboot, this time the EVE-NG will be booting with the IP address using which we can log into its web UI using username admin and the provided password. Now the secondary reboot is completed and EVE-NG is booted. Now we are able to see the IP address as 192.168.1.201. Let us log into the system using the username root and with the provided password and check for the PNet0 interface IP address, which is the EVE-NG system IP address. And let us check by pinging the gateway. Ping 192.168.1.1. Now I am able to get the response. So that means my system is now ready. Let us check the web UI, that is http:// and EVE-NG IP address. It is not HTTPS, it is HTTP. And the username is admin here and provide the password. Now I am able to log into the system. Now EVE-NG is ready for the simulations. Once EVE-NG web UI is working, now it is time to upload the network or security device images. To upload the images, we can use the command prompt since Windows command prompt nowadays comes with WinSAP client. To demonstrate the process in an easy way, I am going to use the WinSAP application. Open WinSAP application and connect to the EVE-NG server as root user and upload the images to opt, unit lab and add-ons directory. And in that directory, we need to place the IOL images in the opt unit lab add-ons IOL bin folder, and the remaining images are basically placed on the add-on stroke to a new directory. Now I have access to the EVE-NG using the root user, and I'm going to copy the IOL images and IOURC file to the EVE-NG. And IOL images are the software images, and IOURC file is basically my license. Once the IOL file is copied, then go to the QEMU directory and copy the remaining images that you want to run on the EVE-NG. That may include the ASAv and Cat8K or 9K, CSR or ISRv, and NXOS or SD-WAN, iOS XR, vIOS, etc. or Arista EOS. Let us start with the IOL images. Log into the EVE-NG via CLI as a root user. Check the disk space for available space and go to the IOL root directory and check the images availability. That is add-ons IOL bin. There, ensure that IOURC file is existing. Otherwise, you may have the images, it will not function properly. And once everything is fine, you got the license, that is IOURC, and you got the images, that is with extension .bin, then fix the wrapper permissions and go to the EVE-NG lab, create a new lab and load the devices and then check whether they are functioning properly or not. Currently, I have executed the wrapper permit. I have executed the command to fix the wrapper permissions. Now we are at the EVE-NG UI and create a new folder, that is devices under test DUT. In that folder, you create a new lab, that is IOL. Okay, once the lab is created, add a node, IOL node. Okay, so I got the total 2 images. This is L3 image. I'm going to add the L2 image too, that is L2. Let's start the images and check whether they are functioning properly or not. When you move the cursor over any of the device, at the bottom, you will be able to see a port number, that is 192.168.1.201.32.769 or 770. So just telnet to the particular application on that port, then you will be able to access the devices. Or otherwise, double click on the device in browser, new tab, you will get the device console. So now these devices are loaded. Switch image is booting properly and router image is also booting properly. The images are functioning properly. Now the IOL devices are working properly, the router and switch, both images. Let us stop the devices and close the lab. The next device that we are going to work on is ASAv, the Adaptive Security Appliance Virtual. Let us create a new lab further. So I have created ASAv lab and just go to the CLI and check whether the image directory is existing or not. If it is existing, check the image naming convention and fix the permissions. So the ASAv image is basically available. It is loaded. Currently, the device naming convention is starting with ASAv9 like that. So let us rename the device with image as whatIOA.qcow2 and fix the permissions. Once it is fixed, just go to the web UI and load the ASAv device. But before that, do not forget to reload the window. Okay. Now I have taken the two devices. I am going to power them on and I am going to connect to the devices using the console. Telnet space the particular EVE-NG IP address and the port number is 32769 32770. It will take some time. Let us wait. Let's wait the boot process to complete properly. Once the boot process is completed, then we will get a prompt with the Cisco ASA and execute enable to enter into the privilege mode. And in some versions or specifically in the latest versions, the system will prompt to set a enable password. So input the new password and confirm the new password and execute the show interface IP brief to check whether the all interfaces are loaded properly or not. If every interface is loaded, then thus we can say the ASAv image is functioning properly. So now the interfaces are visible. In show version, we are able to see the version information as well as the license. And firewall is currently operating in the layer 3 mode and it is a single context. Now the ASA images are basically functioning fine. So let us stop the images and close the lab. Let us create the new lab for Cat8K image. So I have created and let us try to add the image. But before that, let's check the naming convention. So currently the naming convention for Cat8K and Cat9K are basically Cat8000V and Cat9000V. So let us change the name of the particular image to whatIOA.qcow2 and ideally the directory name should be C8000V. Otherwise it will not function. So let's change the directory's name. The directory name should start with C8000V. Then only the system will consider the image that is present in the directory is Cat8K image. And at the same time, rename the Cat9K also. Let us check whether the system will detect it or not. Otherwise, we will rename it to the Cat9KV instead of Cat9000V. And let's fix the permissions and check whether both 8K and 9K images are visible or not. Let's go to the lab and add the node Cat8000V and check whether the image is functioning properly or not. And access the device on the port 32769. It will take some time for the image to boot. Once the Cat8K image is booted properly, we will get a prompt saying, would you like to enter the initial configuration dialog? Yes or no. I recommend you to execute the no to skip the process. After executing no, system will prompt you to set an enable secret password. Once the enable secret password is provided, you will get another prompt to save or ignore configuration. Here, I will recommend you to proceed with the option 0 to ignore and continue with the system. Once you have provided the option 0 and proceeded, The system will take a minute to provide you the router prompt. Once the router prompt is provided, you can execute the show IP interface brief kind of commands to verify whether the system is functioning properly or not. For Cat9K device testing, add a new lab and check whether the device is able to visible here or not. Before that, try to check the naming convention. The device name must start with the Cat9KV, but here it is C9000V. So let's rename it to Cat9KB and then check the image name. Let's enter into the directory and rename the device image to vioa.qcow2. Move the original file vioa.qcow2. Enter, fix the permissions and check whether the device image is getting loaded properly or not. And remember, Cat9K is a heavy image. It requires at least 16 to 20 GB RAM and it will take some time to boot. Add a note. Cat9KV is available. Provide the sufficient RAM. Currently, I'm going to give 20 GB RAM. Okay. Save and start the device and access the device on port 32769. Currently, the device is booting. The calculated and expected SHA values are perfect, so that means it is not corrupted. Yes, the device is booted properly. Execute no to skip the initial configuration dialog and provide some password, and execute 0 to skip the saving process. Let's wait. Now execute the show version or show IP interface brief to check whether the system is booted properly or not. Show interface description is basically showing the all interfaces, so that means the image is booted properly. Now just go to the UI and stop the device and close the lab. Let us create a new lab for the CSRv device. Go to the CLI and change the file name to the vioa.qcow2. Change the directory. Ignore the ISO is not needed. Only we need to change the .qcow2 extension file's name to the vioa.qcow2. And keep this in mind. Just keep one thing in mind, that is, whenever you are going to pick the CSRV file for EVE-NG or GNS3, you try to pick the image name with the serial keyword in it. And accidentally I have executed the fixed permissions here, but ideally the folder directory's name should be CSR1000B-NG. Otherwise, what will happen in EVE-NG? There are two profiles. One is CSR for version 3.x, CSR for version 6.x and above. So currently the version that we are attempting is 17.x. So we need to use the CSR1000B-NG. Okay. Select the compute, save, and spin the device. Once we power on the device, that try to access the device via CLI. It's basically telnet colon port number 32769, and it won't take much time for a CSR image to boot. Just execute no to skip the initial configuration dialog, and you will get one more pop-up. Would you like to terminate the auto install? Yes, I would like to terminate the auto install. Once all services are up and running, just go to the enable mode and execute show version to confirm the iOS XE version. Just go to configuration mode and set a host name. Yes, we have checked the version. So that means the device is functioning properly. We can go to the lab and we can stop the device and we can close the lab. Now we are going to see the ISRv image. How to load the ISRv image. ISRv is basically integrated services router virtual, and we need to execute the change directory to the ISRv directory where we can find the ISRv image, and we need to rename the particular image to the vio.2cow2. Once we have renamed the image, then we need to connect to the image using the guest shell. And once we have connected to the particular image using the guest shell, we need to execute few commands. Then we need to modify the grub file. So basically we are going to remove a VM console keyword in two places in the grub.cfg. Okay. So we have connected to the audio.qcow2 using the guest shell, and I am executing the image, and I am just mounting the file system. Once I am mounting the file system, then I'm going to change the grub.cfg file. So basically I am using the VI editor to make changes to the grub.cfg, and in that file, wherever the line is starting with the Linux, in that line, if I found any VM console in capital letters, then I will remove that particular keyword and I will save, and I will quit from the guest shell. Okay. If you see in the Linux spaces /packages.conf, after hardware equal to virtual, usually sometimes we find VM console. There is a keyword. Okay. In these two lines. Okay. So in these two lines, if anyway, if you found that VM console, just remove it and save it and just quit it. Okay. Now you execute the fixed permissions. That means your ISR image will be ready. and just go to the lab and simply create a lab, that is ISRv lab, save it and add ISRv device, and it won't take much time to spin or start it, and it is again 32769. Just connect it and let's wait for the device to boot. Now the ISRv image is basically almost ready. It's almost ready. And once the ISRv image is ready, you are going to get a configuration dialog, the initial configuration dialog that is basically with a prompt yes or no. There you need to say, no, I do not want to continue with the initial configuration dialog. Then we will get one more prompt, that is, would you like to terminate the auto install? There we have to execute the yes. Then we will get a ISRv shell, and we need to go to the enable mode, and we need to go to the configuration mode, and we will configure the host name for the particular router. And once the host name is configured, then we will come back to the enable mode and we will execute the show version to check the ISRv version. Once this process is completed, then we will come to a conclusion that ISRv image is working properly. And this guest fish shell modification or the grub modification at the guest fish is basically that we are going to do for this ISRv image only. None of the other images has got this option, or they don't need basically. Okay, now the image is booted. Go to enable mode. I'm just going to configuration mode, changing the hostname to AV1. Okay. And let us check the execute the show. I'm going to execute the show version and check the iOS XE version. The next image that we are going to see is for the Nexus OS. That is for the Nexus devices. So let us go to the directory of the NXOS and check the image name. If the QCOW2 extension file is having the name as SATA SATA-A.QCOW2, it's fine. Otherwise, we need to rename the particular image as SATA-A.QCOW2. Once the rename process is completed, we need to execute the permission. Now, I'm just renaming the particular image name and I'm going to execute the permissions. Once the permissions command is executed, now this image is ready to be called to the lab. So I'm creating a new lab for the NXOSv. Now the lab is created and I'm just calling the Nexus 9000V image here, and I'm going to allocate the RAM as 10 GB. Of course, the documentation says you need to allocate the 8 GB, but still I am going with the 10 GB because the image is latest. It might require some higher amount of RAM. The device is started. Let us access the device via console. And since the NXOS Cat9K and the iOS XR devices, these are the devices requires a lot of amount of memory, lots of memory. Okay, so these devices even take a lot of amount, lots of time to be booted for booting. Okay. Once the boot process is completed, you are going to get a pop-up for the power on auto provisioning. Power on auto provisioning means basically if you have any DHCP server and all the configuration, if it is pointing towards some server where you can fetch a configuration and all. So that stuff we do not want to go to. So simply we can execute yes to skip the horon auto provisioning. And the next option that we are going to get is basically, would you like to enforce a secure password or not? Currently I do not want to enforce any kind of secure password. I would like to keep a simple password, so I'll say no and I'll provide my password. Then we are going to get, would you like to enter the basic initial configuration dialog or not? I'll execute no and I will proceed with the regular configuration. Okay, after executing no, the system will take 10 to 20 seconds depends upon allocated memory, and the system will provide you the prompt. Okay, I do not want to enforce any kind of secure password standard because previously for on auto provisioning I have already pressed yes. Here I am saying no, I'm providing a simple password. There I'm going to get the basic configuration dialog. I'll execute no and I'll wait for 10 to 15 seconds. Then the system will prompt for the authentication. I'm simply providing the authentication, that is admin, and the password that I have configured. Now this is the switch. Show version shows the device version. Show IP interface is not going to show anything because none of the interfaces are layer 3 or assigned with IP addresses. Now the device is currently booted. Once the device is booted, you can go and check with the show interface status or show interface description to see how many interfaces that are available. Okay, show interface status shows total 64 interfaces. The same can be confirmed with the show interface description. Okay, now our device is ready and we can simply stop the device and we can close the lab. Now we are going to view how to add the virtual IOS and virtual IOS layer 2 image. Basically it's a virtual router and virtual switch images to the EVE-NG. So let us go to the directory starting with the vIOS, that means it is a router image, and rename the file to the virtioa.qcow2 and fix the permissions to use the router image. Let us execute the fix permissions command. And let's go to the virtual switch image directory, that is the directory starting with the vIOSL2, and rename the particular image file to the virtioa.qcow2 and execute the wrapper permissions command again. Now this virtual switch is ready to be used in the Cisco EVE-NG. Create a new lab with vIOS L3-L2. So let's put it in the capitals. Yes, new lab is, I have just created the new lab and add the virtual router and virtual switch images and just provide a connection. Then we are going to power on the particular images. And while adding the devices and provide at least 2 GB RAM, it is, the recommendation is 1 GB RAM, but I suggest you give 2 GB RAM for smooth functionality. If your system doesn't has much RAM or much memory, then you are good to go with the 1 GB RAM. There should not be any problem. Only one thing, the boot time is going to be much higher. Okay, the devices are started and connected to both devices on its designated ports, that is the router is on 32769 port and switch is on 32770 port. At any point, if you got the particular initial configuration dialog, execute no and continue with the normal configuration mode. And once these devices are booted, let's execute the show version command to check the version and uptime of the particular device, and repeat the same process for the virtual switch too. And after that, execute the show interface description command to see whether the interfaces are loaded properly or not. So I got the initial configuration dialog for the router. Let's execute no to proceed with the normal configuration. Server switch, okay. Show version, switch has booted properly. Show interface description, the interfaces are loaded properly. Let's go to the router. Show version. It's iOS 15.9. In show interface description is showing the all interfaces, all available interfaces. If you observe one thing, the switches interfaces are by default up and the router interfaces are by default down. And let's stop the lab. Sorry, stop the devices and close the lab. Now we are going to add the iOS XR image, that is XRv9,000 image. For that one, we need to keep one thing in mind, that is the QCOW2 format must have the VRR option in it. So while downloading it from the Cisco official website, ensure that the VRR image is supposed to be downloaded. So just go to the directory and rename the file to the vio.qcow2 and fix the permissions. Now add the device, the XRV, and provide the 20 GB RAM, that is 20480 MB memory, and save and power on the device. Just connect to the device, and this device will take 15 to 20 minutes time at least if you provide this much amount of memory, or at least at 10 minutes. Please give the 10 minutes, or please wait for 10 minutes for the device to boot properly. And let us assume the device is booted properly. Still, if you are not able to see any interfaces, wait for 10 to 20 minutes more, because once the image appears to be booted properly, still there are chances that the all services might not came out. So because of which you are not able to see the interfaces. So let's wait for 10 to 20 more minutes after the image has been booted successfully. Then you may see the interfaces. Okay. And keep one thing in mind. I am repeating it again. While downloading the image, you need to download the VRR image. Otherwise, it will not function in the Cisco EVE-NG. So now the system is booted properly. The system is prompting to set a username and password. Once you have set, it will prompt for the same username and password using which you have to log into the device. If you see, the interfaces are not visible here. I have executed the show interface description. Still, now see, it took some time to boot because I have provided the 20 GB memory and good amount of CPU. The system has booted in a fast manner. If either of this is lacking or the resources are not sufficient, the system will take a lot of time. So let's stop the lab devices and close the lab. Let's check how to add the Cisco SD-WAN images. Just create a new lab for SD-WAN. Now go to CLI. Just go to EVE-NG. And let's try to add the vBond, vEdge, vSmart and vManage devices. Let's list the devices and go to the vtbond directory and rename the particular vBond image to qcow2. vio.qcow2. Next go to vtEdge. And it is appearing as a vBond image because nowadays Cisco is not releasing any new vTedge images. Rename the same file also as a vio.qcow2. Let's go to vtsmart. Let's rename this image is also as a vio.qcow2. But for VT management, we need to rename its image as vio.qcow2. Along with that, we need to create an additional storage since it is a controller. vio.qcow2 and an additional image or an additional disk is supposed to be created with at least 250 GB space. But in this case, this is a hypervisor or it is a simulated environment. So I am going to create it with 100 GB. IOB what I will be to go to, it will fail because I didn't provided any size parameter. So I'm going to give 100G since it is a simulated environment. Now I need to fix the permissions and I need to call those devices in the lab. I've executed the fix permissions. Let's call those devices in the lab. Okay, Viptela, VBON, increase the RAM 2048. Next, add VTH. It doesn't matter whether we need to add it or not. Why? Because nowadays Cisco is not releasing any VTH images. With smart, add 4GB RAM. Next, we manage at 20GB RAM, or we can keep the same RAM. It's up to us. And let's power on those images. Let's check the port numbers 327692, 32772. And this process may take some time for the manager, and manager may need to be performed with some additional configuration, whether how you are going to use this node for compute or storage, or for compute and storage both. Okay. And if you are going to use it for the compute and storage, then which disk that you are going to use for the storage. So these options need to be provided as a manual input for the vManage. So the vBond is booted. vEdge is also showing as vBond. You can ignore that. For vSpot, we have set the password. For vManage also, we are setting the password. We are going to use the particular node for the compute and data both. So I'm going to provide the option 1. Yes, I'm sure. So I'm going to use the VDB, that is 100GB disk that I have created additionally. So I'm going to put input 1. Would you like to format VDB? Yes, I would like to format. Yes, it got booted. Okay, now Cisco EVE-NG is ready to create any kind of lab. Thank you. To answer the few questions, where can we download the software image? That is, we have to access the www.eveng.net and we need to download. And where can we get the image files to operate with? You have to log in to the https://software.cisco.com/download/home and go to the individual device section and you need to download. For that, you need to have a valid contract. And at the same time, there is a second option that is available. If you do not want to go and search for the images, you can simply go to the CML, that is Cisco Modeling Labs, and download the reference platform images, and there you can find your desired images which can work. Most of the images will work with the Cisco EVE-NG. Okay, but for that also Keep one thing in mind, you need to have a valid contract. Thank you. Here I end my session.